one of the key assumptions of the analysis of variance test is that we don't have groups that have significantly different variance within the group. So remember that what we're trying to do with an ANOVA is we're trying to see if the means between, across these groups is significantly different. And the way we do that is by testing whether there is more within group variance or across group variance. And so if there is significantly more across group variance, that means that we can say there's a significant difference between the groups. So the club makes a significant difference in terms of how far you can hit the golf ball. Okay, so you think about how the assumption, so that assumption that that the variance for club 1 and the variance for club 2 and the variance for club 3 is about the same. And you think about why that would be important for the validity of the ANOVA. Okay, so let's think about if, let's say, club 1 and club 2 had about the same variance, but club 3 had a huge amount of variance. This would have the effect of inflating the within group variance. And the result would be that you might fail to reject the null hypothesis and incorrectly. And that would be a type 2 error. And, the other way, if let's say, club 3 had much less variance than the other two, then what that would mean is that would deflate the within group variance. And by comparison, the across group variance would look like more. And so we would have the potential to, incorrectly reject the null hypothesis. And so we would be making a type 1 error in that case. So an important part of the ANOVA is that we satisfy this assumption. Now, the variance can differ a little bit. The key is just whether it's a very large difference. Very large differences in the variance across the group, variance within each group, can significantly undermine the results of the ANOVA test. So there's a test for determining whether in fact the variance, each of these variances is significantly different. And except for a couple of steps, it's really identical to the ANOVA test. We just have to do a couple of things first. So the procedure is this. Okay, so we're going to be doing another hypothesis test, only this time we're going to see if we can reject the null hypothesis that all of the variances are different. The null is that all the variances are the same. Okay, so notice that standard deviation symbol squared means the variance. So that the variance for each group is the same, and the alternative hypothesis there would be that they're not all the same. Okay, so we're not saying that they're all different, but we are, the alternative is that they're not all equal. Okay, so if we reject this, then that means the variance is significantly different, and so therefore the results of the ANOVA are potentially invalid. Okay, so that's the Levene test. And oftentimes you do this after your ANOVA to verify whether you have satisfied that assumption that the variances are all equal. Okay, so the way we do this, and I'm going to just demonstrate this by doing a problem, is we calculate the absolute value of the difference between each value and the median for that group. Okay, so each group is going to have a median, and we take the absolute value of the difference between the value and the median, and then we do an ANOVA on these absolute differences. Okay, so let's go ahead and do a whole ANOVA problem, and then see how we go about doing that Levene test. Okay, so this problem, says that we're looking at burger, chicken, pizza, or sandwich, and the average sales per unit. And so the first question is, whether there are significantly different sales, whether the type of product makes a significant difference in terms of sales. Okay, so that's going to be our main test. And so, this first one, well, let's take a look at the data first. And so this problem kind of represents, one of the things that you tend to face when you're dealing with data is that you sometimes have to do a lot of what's called data wrangling, kind of moving it around to make it a little bit more, amenable to the kind of analysis that we're doing. And in this case, we have just, it might be a realistic way of storing this data. We're recording the sales of each item, but this isn't really organized in a way that makes it convenient for us to do the ANOVA, at least as far as the data analysis tool pack. So we're just going to, change this around. So we have these 4 groups. We're going to have a sandwich group, a chicken group, a burger group, and a pizza group. Okay, so 4 different groups. And then it might be an easy way to move this if I just sort by that column. Okay, then I have all of my observations for burger together. So I'll go ahead and just, okay, so those are all my burger observations. Here are all my chicken observations. And here are my pizza observations. And finally, the sandwich observations. Did I get all those? Okay. And notice we have different numbers of observations, which is totally fine. It is not assumed that you have the same number of observations for each group for the ANOVA. Okay, so that's not one of the assumptions that we make. Now, obviously, you need to have the same number of observations if you're doing like a paired samples t-test, but you don't need that requirement here. Okay, so the first thing we're going to do is, well, let's go ahead and back to the question. So now we've got 4 different groups, and we are going to test whether the 4 means are the same. And so the key, the starting null hypothesis is going to be that all 4 means are the same, and the alternative is that they're not all the same. Okay, so there's that. Okay, and so now we need the F statistic. Okay, so this is going to tell us whether we can reject this null, and we do this by performing the ANOVA. So go to data analysis and ANOVA single factor. Now the single factor is of course the product type. Okay, so the product type is the factor, and we have 4 levels of the factor: sandwich, chicken, burger, and pizza. So these are called levels, and the factor itself, there's just one factor. Okay, you can imagine there might be a second factor, which would be like the city that it's sold in. So then we would have 2 factors, right? You'd have the product type and the city, and so for city you might have 10 different levels, but in this case we have 1 factor that is product and 4 levels. So that's why it's called single factor. Okay, so the input range is here. I'm just going to select the whole block so that everything is included. It is grouped by columns with the labels in the first row, and I believe they asked about the 1% level of significance. If it's not a big deal. Okay, and okay, so that should be good. Okay, so they want 2 decimals of precision here, so I'm going to set that, and I see right there that is where my F statistic is. So remember, that's just the ratio of these 2. Okay, so it's 2.89, so I'll come back here, 2.89. Okay, so we're still just doing the ANOVA part. Okay, so determine the critical value. Well, as long as I put in the my alpha correctly on that last dialog, then this should be the right answer, 4.42. So this is the critical value, and so if the F statistic had been larger than this, then we would have rejected the null hypothesis. Okay, so let's check if that's right. Let me go and show you how that would be calculated if you wanted to do it manually. So this critical value depends on only 3 things: your desired level of confidence, your numerator degrees of freedom, which is right here, and your denominator degrees of freedom. Okay, so you can find that value manually by doing f.inverse. So remember that those inverse functions go from a probability to a critical value. And so the probability corresponding to a 1% confidence level is 0.99. Okay, so degrees of freedom numerator is right here. Degrees of freedom denominator is right there. So remember, this is just number of groups minus 1. This is total number of observations minus total number of groups. Okay, so and if we round that, we'll see that it's the same as that. Okay, so there's that part. Okay, so this is not larger than the critical value. Notice we only have one tail test when we're doing an ANOVA. So this we're going to not reject, okay, and say there's insufficient evidence of a difference in sales. Okay, so basically they all products sell the same. That would be the managerial conclusion. Okay, so now is where we get into the checking that we're satisfying the assumptions of the ANOVA test. And the assumption is that the variances within each group are approximately the same. So that would mean if we look at these 4 groups, so let's see, the variance of, and I'll go ahead and select all these. So the variance there, okay, so each of these groups is going to have a variance. And so we're going to test whether these are close enough that the ANOVA test would be valid, okay? And, I can't do it by eyeballing it. I can't really tell if, it seems like there would be a difference, but we need to be statistically rigorous about this, okay? So we're going to go ahead and do that Levene test, which starts with the null hypothesis that the variances are all equal, and the corresponding alternative hypothesis is that they're not all equal, okay? Okay, and so now we have to find that F statistic. Okay, so there's a lot that goes into finding this. This is like the main point of the test. So let's go ahead and follow the instructions, and I'll just delete these. Okay, so the first thing I need, so going back to the very densely expressed instructions right here, you first compute the absolute value of the difference between each value and the median of the group. Okay, so let's do that. So we'll find the median for each group. So I'll just do median for, then if I do it this way, I can copy. Okay, so this gives me each group's median. Okay, so now what I want to do is reproduce this data where instead of just having the raw data, it's going to be those differences, those absolute differences. Okay, so this is the median for the group. So what I want to have right here, this is going to be equal to this value. Well, let's do the absolute. So the absolute value of this minus the median for that group. Okay, and we'll make it an absolute reference. Okay, and why is it 0? Well, because that's the same as the median. Okay, so we'll just copy those down. Okay, now for chicken, same thing. So we're going to do the absolute value of this minus the median for the group. Okay, and again, we'll just drag that all the way down so it pastes it all the way down. And there are shortcuts that we could take here, but I just want to try to make sure we understand what we're doing here. Okay, and same thing, the original value minus the median, and then we'll do it for the pizza group now. So it's going to be the absolute value of this minus the group median, and you can do F4 to do absolute reference like that. Okay. Okay. All right, looks like everything was done correctly. Okay, so now what I'm going to do is I'm just going to do an ANOVA only on these values. Okay, so the first time I did the ANOVA on the raw values, and now I'm doing the ANOVA on the absolute value of the differences from the median. Okay, so if I can reject this, then I'm rejecting the notion, the hypothesis that all of these variances are the same. Okay, so now I just do the ANOVA. Okay, so exactly the same way, only this time the data is over here. Okay, same level of significance, I believe. Okay, and okay, again, I'm just gonna, so that I don't have to worry about rounding errors. Okay, so now I have, I read this the same way. the F statistic is 1.38. Okay, and you notice the critical value is the same. Now, remember that the critical value only depends on three things here. It depends on your desired level of confidence, which hasn't changed, your degrees of freedom for the numerator, which hasn't changed, and the degrees of freedom for the denominator, which hasn't changed. So the F critical value is exactly the same for this part of the test too. And so I see that our F statistic is 1.38. Okay, so let me go back here. Now, lots of things can go wrong, as you know, copy and pasting and all that. So let's not be too surprised if something has gone wrong here. But okay, thankfully nothing has. Okay, so determine the critical value. Critical value is exactly the same as I said, 4.42. 4.42. Okay, and so now notice our F statistic is smaller than our critical value, so we're not going to reject, fail to reject. There's insufficient evidence to conclude there's a difference in the variation. Okay, so there's a lot of like double negatives to sort out there. But basically, our conclusion is that the variances are approximately the same. You know, the variance of burger, chicken, pizza, and sandwich is approximately the same. Okay. Okay, and so what does this mean? So this makes the ANOVA that we did in the first part more reliable. Okay, because if differences in the group variances can impact the validity of the F test. So let's see which of these corresponds to that. It makes the result in part A less reliable. No. So it makes the result in part A more reliable because large differences in the group variances can seriously affect the validity of the F test. Okay, and that sounds right to me. Okay, so what we're doing with the Levene test is just checking that we're satisfying one assumption of the ANOVA, and that's that the variances across the groups, the variances within the groups is about the same.